Hello and welcome to our Lesson 5 guided notes where we'll be talking about adding and subtracting mixed numbers. The goal is for you to be able to say, I can use different ways to add or subtract mixed numbers to solve problems. Make sure you've got your pencil ready, you've got your earbuds in, and let's take a look at our key terms. Our first key term is improper fraction. It's a fraction with a numerator equal to or greater than the denominator. For example, 6/6 or 8/5. Next we have a mixed number. It's a number that consists of a whole number and a fraction. For example, 5.5. Next, let's have a look at estimating addition of mixed numbers. You can estimate a mixed number using its whole number part. If the fraction part is close to 1, you may choose to add 1 to the whole number part and use that as your estimate. For example, if we have 2 7/8 and 1 1/3, what does that look like in a picture? 2 7/8 looks like this. Here's one hole, two holes, and then we've got 7 out of 8 of those colored in there. 1 1/3 looks like this. Here's 1, and there's 1/3 colored in. So, when we have 2 7/8, well, that's very close to 3. 2 7/8 is very close to 3. And then we don't have to change a thing for the 1 1/3. We can just add those two things together. And when we add them together, we get approximately 4 1/3. We add the whole numbers together and keep the 1/3. So again, this is just an estimate. It's not perfect, but it gets us in the right ballpark. Next, let's have a look at rewriting a mixed number as an improper fraction. You can rewrite a mixed number as an improper fraction by thinking of each whole as an appropriate number of halves, thirds, fourths, and so on. So, for example, if I have 5 1/4, the shape that I can fill out looks something like this. I've got 5 wholes, right? And then 1/4 of the last shape. But how many fourths is this? Well, it's going to be 4/4 here, that's one whole, and then I'm adding another 4/4, and another 4/4, and another 4/4, and another 4/4, and finally we've got 1/4 right there. If I add those all together, now I've got 4, 8, 12, 16, 21. So I've got 21/4. That is my improper fraction. I've changed this mixed number here, and I've made it into an improper fraction. Now, this way of doing it is fine, but it takes a little while to do. And if you were paying close attention, you may have noticed that right here we have some repeated addition going on. There is another way of saying repeated addition is just multiplication. So we can actually save some time if we just use multiplication instead. The way you would do it is you would multiply 5 by 4/4 and then add that 1/4 back on, because that is what's happening here. We've got 5 groups of 4/4. So how many fourths do we have here? Well, we've got 4, 8, 12, 16, 20 fourths. So this becomes 20 fourths plus 1/4. And when we finally add those two together, we've got 21/4. We get our same result, but it's a little bit faster. Next, let's look at adding whole number parts and fraction parts. So first we've got 3 1/3 right here, and we've got 1 2/5 here. What we're going to do is rearrange things a little bit so that our whole numbers are together, and we're going to also add our fraction parts. The difference is that we are going to multiply those fractions by 1 in order to find an equivalent fraction so that they share the same denominator. So we're still adding 1/3 and 2/5. I'm just multiplying them by 1, not changing their value at all. So let's rewrite this now. 3 plus 1 is 4, and then let's add our fraction parts with their new equivalent fractions. So 1 times 5 is 5, so the numerator is a 5, and the denominator is 15. And then we'll add 2 times 3, which is 6, and 5 times 3 is 15. Now it should be fairly simple to add everything together. We have 4 and 11 fifteenths, and there is our final answer. In our next example, we're going to see what happens when the sum of the fraction parts is greater than 1. We're going to start much the same way, where we rearrange things so that the whole numbers can be added, and then the fraction parts can be added as well. We're going to multiply by 5 over 5, but we're still adding 2/3. It's just finding an equivalent fraction. And we're going to add it to the 4/5, but we're going to multiply that by 3 over 3, which is just 1, and keeping the same value. Now, when we add the wholes together, we have 4, and we're going to add our new equivalent fraction. It's 10 fifteenths, and our other equivalent fraction is 12 fifteenths. When we put it all together, we've got 4 and 22 fifteenths. This is where it's a problem. We now know that this is an improper fraction. So we don't want an improper fraction and a mixed number all together. That's no good. What we can do is take that improper fraction and recognize that there is at least one 15 fifteenths in there, which is just 1, right? So now we're asking ourselves, 15 plus what is 22? So how much do we have left? Well, that's 7. 15 and 7 is 22. So this 22 fifteenths can be broken down into 1 and 7 fifteenths. So this becomes 4 plus 1 plus 7 fifteenths, which is just 5 and 7 fifteenths. And there's our final answer. That's it for part 1. Join me next time in part 2 when we look at subtracting mixed numbers. That's it for today. Thanks for watching.